Remember, the desired output is a probability distribution over all tokens that might come next. For example, if the very last word is professor, and the context includes words like Harry Potter, and immediately preceding we see least favorite teacher, then a well-trained network that had built up knowledge of Harry Potter would presumably assign a high number to the word Snape. This involves two different steps. The first one is to use another matrix that maps the very last vector in that context to a list of 50,000 values, one for each token in the vocabulary. This matrix is called the unembedding matrix, and we give it the label WU. Then there's a function that normalizes this into a probability distribution. It's called softmax. The idea is that if you want a sequence of numbers to act as a probability distribution, say a distribution over all possible next words, then each value has to be between 0 and 1, and you also need all of them to add up to 1. However, if you're playing the deep learning game, where everything you do looks like matrix vector multiplication, the outputs that you get by default don't abide by this at all. The values are often negative or much bigger than 1, and they almost certainly don't add up to 1. Softmax is the standard way to turn an arbitrary list of numbers into a valid distribution in such a way that the largest values end up closest to 1, and the smaller values end up very close to 0.